Hi everyone, I'm Janel Martell and I'm a current graduate student at Harper University studying under the supervision of Dr. Yuri Montanelli, where I recently had the pleasure to attend the British Society of Animal Science conference, and I was able to present on behalf of our research group regarding cardiovascular measures to infer about feed efficiency in beef cattle. With this opportunity, I was able to travel to Dublin and I got to see some iconic Dublin landmarks and eat some great food with some authentic Dublin entertainment. During the days, I got to see some really interesting talks on innovations in agriculture, and I got to present on our own research. So beef cattle have a poor feed conversion ratio of 6:1, with feed comprising upwards of 70% of production costs. However, improving feed efficiency could reduce these costs and environmental impact while helping to satisfy growing meat demand. One measure for feed efficiency is through residual feed intake, and this is the difference between observed versus predicted feed intake. It is independent from production traits, moderately heritable and repeatable. However, improvement has been limited due to the cost, labor, and time for feed intake determination. Therefore, measures more viable in a commercial setting must be explored. An alternative measure is through physiological indicator traits, and research suggests that lower FI cattle have a lower metabolic demand based on various parameters that have been associated with heart function. However, a survey looking at precision technologies demonstrated the lack of usefulness and adoption of heart rate monitoring. And although heart rate could serve as a potential proxy for RFI, the basis of its association must be further explored to see that it is cost-effective and robust. Therefore, it is hypothesized that further assessment of heart rate, monitored during rest and stress, could aid in explaining the biological basis of its association with RFI. The objectives were to assess the relationships of heart rate with RFI across stress severity and duration, and second, to evaluate the variation in RFI explained by different measures of heart rate. To do this, 165 heifers, bulls, and steers were used, predominantly of Angus and Simmental breed, and they were subject to productive performance evaluation over the course of 115 days, during which time body weight was recorded and body composition was determined by ultrasound. Individual feed intake was also recorded, with cattle given ad lib access twice daily to the diet shown in the table, from which average dry matter intake was further calculated. A regression on average daily gain, body weight, and body composition traits demonstrated that this was the most suitable model for predicted feed intake, from which we could further calculate for RFI. Heart rate was continuously recorded using an external electrode and then ultimately divided into overnight, transport, and abattoir segments. Within each of these segments, the highest 20% heart rate, average heart rate, and lowest 20% heart rate were determined for each animal. All statistical analyses were completed using SAS. First, error and normalities were considered, and significant fixed effects and covariates were determined using the GLM select procedure. Residuals were identified using GLM, and Pearson's correlation coefficients were measured with the core procedure. The reg procedure was used to determine the variation in RFI explained by each heart rate trait, and the linear and quadratic effects of each trait on RFI. Finally, a partial R-squared was used to look at the explained variation in RFI by each heart rate trait. The results show that overnight and transport heart rate and low frequency traits were not correlated with productive performance. However, positive correlations were observed between abattoir heart rate traits and low frequency traits with dry matter intake. Then when looking at the resting heart rate with RFI during the overnight assessment, the positive quadratic relationships suggest that heart rate increases with RFI at an increasing rate, while the negative quadratic relationship supports that lower FI cattle have a lower resting heart rate that does not appear to be due to influences of sympathetic reactivity based on the lack of association of low frequency trait with RFI. When we look at the high stress imposed during the abattoir segment, we see that stress severity and duration changes the relationships we see with heart rate and RFI, And the negative linear relationship between average abattoir heart rate and RFI is in agreement with a previous study by this research group, where lower FI cattle have a greater response in heart rate to a novel acute stressor, and this does appear to be influenced by sympathetic reactivity. Then when looking at the low stress imposed during the transport segment, we see that there is only a relationship between the average heart rate transport and RFI, and this positive quadratic relationship does not appear to be influenced by sympathetic reactivity, but rather may be due to decreases in HPA axis reactivity. However, this requires further evaluation. Then when looking at the variation in RFI explained by our heart rate model, we plotted the observed versus predicted feed intake. We see that the model is able to explain a significant amount of variation in RFI. And then when taking a closer look at the pie chart, we see that the abattoir and transport heart rate traits contributed the largest percentage to this model. And this may be due to the additional mechanisms relevant to the stress response. And that's actually further supported by the contribution of the low frequency traits to these two segments. And then when taking a closer look at the biological basis for this, we understand that RFI is an energy reserve with various uses including the stress response, which may be contributing to the differences in relationship between heart rate and RFI when looking at resting heart rate during our overnight assessment compared to stress heart rate during our abattoir and transport assessments. And this really comes down to stress perception and the idea of coping style. And this is what I'm actually looking to explore further. In conclusion, feed-efficient cattle have a lower resting heart rate, which appears to be due to increases in metabolic efficiency, not sympathetic reactivity. And during stress, they appear to have a more specific and energy-conserving stress response that does not appear to impact productive performance. To our knowledge, this study is the first to look at the relationship of heart rate with RFI during rest and stress on a continuous scale in beef cattle. Therefore, with further investigation, we could see heart rate being applied as a potential proxy for RFI in beef cattle. Finally, I would like to acknowledge those who supported this study and thank you for listening.